Hello everyone, welcome back to another remote sensing lecture video. And in this remote sensing lecture video, what I want to do is I want to continue our discussion on the error matrix. And in specific, I want to sort of build off of this base that we generated here in the previous video to delve a little bit more into what we can get from this, just in terms of numbers that are directly on the table. So that we can, when we build into some of the metrics that we're going to generate in the next couple videos, you'll have a really solid understanding of what those metrics are pulling on in terms of what they're pulling out of the table, so you'll have an even better understanding of what those numbers mean. And that's going to, again, be very important to understanding the bulk of this module. And so what I want to do here is I want to draw your attention to something. So in the previous video, when we were setting up this error matrix, we said that this cell right here were the data that we had called water, that the map also called water. And so what I want to draw your attention to is the fact that these diagonal values these are the times that the model got right. Okay? So I want to sort of draw your attention to the fact that the diagonal of the error matrix is what the model got right. Right? Because that's going to play a very important role in pretty much all of the calculations that we're going to do in the next videos, is understanding that at a minimum, this diagonal is what the model did well. Okay? So let's talk for a second about what we can do with the numbers we have here. Well, the first thing we could do is we could just add up all of the numbers, right? We could add up all of the numbers. So if we do that, right, 7 plus 2 plus 6 plus 7 plus 2 plus 1 plus 2 plus 1 plus 4 plus 1 plus 7, right? The total number of validation data. Right, in this case we would get 40. Right, this is the sum of all cells. Okay? We can get the diagonal of the error matrix, which is what the model got right, right? So if we sum the diagonal, right, that'd be 7 plus 6 plus 7 plus 7. That's going to be 21 plus 6 is going to be 27. Right, so that's two things we can do. We can sum the entirety of all of the cells, and we can sum the diagonal, which is the parts we got right. Right, we can also sum the rows. So if we sum the rows, we can do what's called the row sum. So the row sum for this would just be 7. Right, the row sum with this would be 2 plus 6 plus 2 plus 1. That's going to be 11. Right, the row sum for this is going to be 7 plus 2 is equal to 9. And the row sum for this is going to be 1 plus 4 plus 1 plus 7. It's going to be 13. Right, so all I did was just sum the rows. Okay, hopefully that makes sense. Right, we can do the same thing with the columns, right? We can do a col sum. So this would be 7 plus 2 plus 0 plus 1. The column sum here is going to be 10. Right, this would be 6 plus 4. That's also going to be 10. This is going to be 2 plus 7 plus 1. So this is also going to be 10. And this is going to be 1 plus 2 plus 7, or 10. Okay. So what I want to do before we move on to the next video is I want to just quickly recap or quickly summarize what these row sums and column sums mean, right? Because we understand the total number of the sum of the whole table is the total number of validation. We know the sum of the diagonal is the times that the model was right. But what do the row sum and column sums mean? Well, the row sums, right? This is the number of times the map was classified. Right? So this 7, right? This represents the number of times that we found a map, the pixel classified as water, was this 7. Right? This 11, right? This is the number of times that we found a pixel classified as forest, right? 2 water pixels were classified as forest, 6 forest pixels were classified as forest, 2 urban pixels were classified as forest, and 1 soil pixel was classified as forest. Right, so this is the number of times that we came across a pixel on the map classified as forest. Okay. What about this column sum? Well, the column sum is basically just going to be the number of validation data in the class. So I'm going to do that in a different color, so we don't get quite so confused. Right, column sum is going to be the number of validation data in the class. The number of validation data in the class. Now, I purposefully constructed it so that I had an equal number of validation data in each class. As you go through in real-world examples, these will not always be the same. Okay? But again, column sum is the number of validation data in each class. Row sum is the number of times that a piece of validation data was classified in that class. So this means that we had 7 validation data classified as water. This means we had 11 validation data classified as forest, and so on. Okay? I know this is a lot. This is going to be, again, this is the fundamental concept and fundamental building block of dealing with accuracy assessment. So if you don't understand what each of these pieces means, right, the total number, the sum of the diagonal, column sums, and row sums, if you don't understand what they mean conceptually, you're going to have a very hard time grasping the actual calculations that we do with them. So if you have any questions, please reach out. Thank you.